Hello everyone. In this video, we are going to learn about transmission parameters. Transmission parameters are also known as ABCD parameters or general circuit parameters or chain parameters. And these were widely used in transmission line theory and cascade networks. Okay. Now, in describing transmission parameters, the input variables, what are the input variables? V1 and I1. So, at what port? At port 1, usually called as sending end. Okay, usually called as sending end, can be expressed in terms of output variables. What are the output variables? V2 and I2, and where they were at port 2, so usually called as receiving end. Okay, receiving end. So that means we are expressing V1 I1 in terms of V2 I2. So according to the two-port network concept, so V1 V2 will be considered as dependent variables, V2 I2 will be considered as our independent variables. Okay, so now let us draw the two-port network. Okay, so this is our two-port network. Okay, two-port network. Now, so this is the port 1. Let me write the names. 1, 1 prime. Second port, 2, 2 prime. Okay. So I'm also expressing the variables here. This is V1, port 1 voltage. This is I1, port 1 current. Similarly, on the receiving side, this is V2, this is I2. Output port voltage and current. So what I told you, port 1 will be considered as sending end. Port 2 will be considered as receiving end. So I'm using a different nomenclature. For sending end, let us write it as VS, IS. For receiving end, the nomenclature should be VR and IR. So here I'm writing VS. VS is nothing but V1. Here IS is nothing but I1. But on the second port side, the current is in this way. Usually in transmission lines, the current will flow from sending end to receiving end. So that's why we need to consider the current direction in this way. So obviously this current can be considered as minus I2. So this current is known as receiving end current. This voltage is known as receiving end voltage VR. Okay, now we are expressing dependent variables in terms of independent variables. So dependent what? V1, I1. Okay, so we are going to express them in terms of output port or receiving end voltages and currents. So this is V2 and this is I2. But what direction we are following? We are following this direction, you can see. Okay, so if we consider that, we have to consider the negative sign. So this is the only parameter that we are getting a negative sign. Okay, so let me write here also V2 minus I2. So now I'm adding the parameters A, B, C, D. Okay, so let us call it as equation 1 and equation 2. So now, so these two equations can be expressed in matrix form also. If we do so, it will be somewhat like this. V1 I1, okay, is equal to A, B, C, D into I1, I2. Okay. Now this matrix is there, no? ABCD. So this matrix will be called as transmission matrix. What we can call it as transmission matrix. Okay. So now let us find the parameters using the conditions. So let me take the first condition. When V2 becomes 0. What happens if V2 becomes 0? It will be replaced by short circuit. So from equation 1, what we can write? So V1 equal to minus B into I2. So what is B1, B now? B is minus V1 by I2. So V by I. So it's a impedance. So unit will be ohms. Now from the second equation, what we can write? I1 equal to minus D into I2. So now what is D? That is minus I1 by I2. So ampere by ampere. So no dimension for D. Okay, so no unit. Now let us go with the second condition. What is the second condition? When I2 becomes 0, what happens? Open circuit will be happening. Okay, now from first equation, what we can write? V1 equal to A into V2. Now what is A? A is V1 by V2. Again voltage by voltage. So no unit, so dimensionless. Now from the second equation, I1 equal to C into V2. Now what is C? C is I1 by V2. So what is I by V? That is an admittance. Okay, so that's why it is measured in mho. Okay, so later after completion of all the parameters and all, we are going to relate every parameter into the other parameters. Okay, at that point of time we'll talk a little bit more. Okay, so now coming to the cascade connection, that is very important. Okay, so let us see how the cascade connection can be analyzed. Okay, so the main use of this transmission matrix is there, no? That is ABCD. So the main use of that transmission matrix is in dealing with a cascaded connection of two-port networks. Okay, so in order to have the discussion, let us consider two-port networks which are connected in cascade. So again, cascade connection means the output of one network will be connected to the input of other network. Okay, so let me draw the network X first. Let us consider that this network as network X. Okay, this one is network Y. Okay, network X and network Y. Okay, so now I'm drawing the terminals. Okay, so these are the terminals, input and output port terminals for network Y also I'm drawing. Okay, now what we can do now? So because it is network X, let us name it as V1X. Okay, so first port of network X voltage. Similarly, here the current is I1X, and on the other side, this voltage, let it be V2X, and this current as I2X. So we'll go for network Y. So what is this voltage? So this voltage is V1Y. This current is what? I1Y. Okay, so now this voltage is V2Y and this current I2Y. So how the cascaded connection should be? That means the output of network X will be connected to the input of network Y, like this. So then we can say this entire connection between network X and Y was in cascaded way. Okay, now here this entire portion will be considered as one single port. On that node, okay, so this V1X will be considered as V1, I1X will be considered as I1, and here V2Y will be considered as V2 and I2Y will be considered as I2. Okay, so this we need to keep it in our mind. Okay, so what I'm doing, I'm writing the transmission parameter equations for network X. Then instead of V1X, input variables should be expressed in output variables, right? So input variables, instead of V1X, what I'm writing? V1. So I'll take another color. Okay, so this is V1. Instead of V1x, I have written V1. Similarly, I1 instead of I1x. Okay, is equal to ABCD parameters for network X. That is, let us say AX, BX, CX and DX. Okay, into output variables. What are the output variables? V2x and then minus I2x. Don't forget to write minus. Okay, because you have to take the current direction in this way while you're writing for transmission parameters. Then it should be minus I2x. Okay, now for network Y. So for network Y, what we can write? This is input variables are what? V1Y and I1Y. Clear? Is equal to, let me write the parameters for network Y. This is AY, BY, CY and DY. Okay, into output variables. What are the output variables? V2y, I2y. Instead of V2y, what we can write? V2. Instead of I2y, I2. Clear? Now, so did you find any kind of pattern, any common points that we can relate these two? Yes. So here you can observe V2x is nothing but V1y. So both the voltages are measured between the same two terminals. So that's why V2x is nothing but V1y. And look at the currents. Look at the currents. How the current direction. Look at the current directions and what could be the relation. So the relation can be I2x. If I consider I2x, what should be the I2y? Are they in reverse directions? You consider the original directions, then you can understand. So both were in opposite directions. Okay, so that's why you may consider it as minus I1y. Now let us use these conditions. Okay, so now from this equation, okay, so V1 I1, I'm rewriting this equation. Let us see how what kind of analysis can be done. So this is AX, BX, CX, DX. Now tell me, instead of V2x, what we can write? We may write V1y. Instead of minus I2x from this relation, what we can write? Minus I2x. Instead of minus I2x, we may write it as I1y. Clear? So now look at the second equation. Are we get the same kind of matrix here? V1y, I1y. So that can be equated to this product. So if we do so, I'm rewriting here. This is V1, I1. It's very simple. By this time, you can able to assess what kind of calculations should be done. Okay. So, but still, I'm writing the entire relations. Okay. So, right. Now, instead of V1y, I1y, what we can write? We may write AY, BY, CY, DY into V2, I2. So if we do the calculation or like product of these two matrices, so some matrix will be getting no. So that matrix will be considered as a total ABCD matrix for this cascaded connection. That means we may write it as V1, I1 equal to A. Here we can't write AX, BX, CX, DX, something not like that. So directly we may write it as ABCD. Okay, into V2. So here, sorry, minus I forgot. Okay, so here also minus I2. So please correct there. So this is minus I2. Okay, right. So now what is ABCD? ABCD is a product of ABCD matrices of network X and network Y. Okay, so this matrix is known as what? ABCD matrix. This matrix is known as overall networks transmission parameters matrix. Okay, so in this way we can analyze the cascaded connection. Okay, so now let us solve a simple problem which is based on transmission parameters. Okay, now so this is a simple problem. So firstly, we need to write the standard equations for the ABCD parameters. So V1 equal to AV2 minus BI2. This is our first equation. And I1 equal to CV2 minus DI2. Okay, so now let us apply the first condition. When V2 becomes 0, what happens? It will behaves like a short circuit. Okay, now from the first equation, what we can write? V1 equal to minus B into I2. So B is minus V1 by I2. Now from the second equation, I1 equal to minus D into I2. So D equal to minus I1 by I2. Now let me draw the network under this particular condition. Okay. So without any sources, first we need to draw the skeleton. Okay. Like this. This is 1 ohm. This is 2 ohm. And this is 5 ohm. Now what is the condition? The condition is V2 0. That means we should not disturb the input port. So write it as it is. So V1, I1. Now what happens? V2 got 0. So that means it should be replaced by a short circuit. Okay, so is that mean I2 0? No. So there will be some current. So this current will be considered as minus I2. Okay, now what should be calculated now? Look at the parameters B and D. So these two parameters are in terms of V1, I1 and I2. So here in this case, V1 is the supply voltage. So there is no need to do any kind of calculation. So if we can able to calculate the currents I1, I2, that is enough. There we get the parameters B and D. Okay, so for that what I'm doing, I'm taking the total resistance. What is the total resistance? 2 parallel to 5, which is in series with 1. So do the calculation, you'll be getting some X ohms. Now find the total current, that is V1 by X, total resistance. Okay, so you'll be getting I1, total current. Okay, so what is the total current? Is it not equal to I1, which is the current coming out from the supply voltage V1? So can be treated as I1. Now, what is minus I2? How you calculate? Use the current division rule. What is the current division rule? Total current. What is the total current? I1 is the total current into opposite branch. What is the opposite branch for 2 ohms? Obviously 5 divided by sum of the opposite branch resistances, that is 5 plus 2. So do the calculations, you'll be getting I2. So you'll be getting I1 in terms of V1 and I2 in terms of I1. Okay, now we can able to calculate the parameter B. What is B? V1 by I2. So keep minus V1 like that. What is I2? That is 5 by 7 into I1. Okay, so still no other element is cancelling. So we can even process this one. So from this relation, okay, I'll be erasing these tick marks. Okay. Okay. Now from this relation, what we can write? V1 as X into I1, right? So we are using that. So minus V1 is X into I1 by 5 by 7 into I1. I1 gets cancelled. You'll be getting some value. Okay, so similarly D. So D is what? Minus I1 by I2. So because I2 is having already I1 term, so don't write any substitute for I1. Keep minus I1 as it is by I2. So look at this relation. So from this relation, what we can write? So this is minus I1 into 5 by 7. So I1 gets cancelled. You'll be getting some value for D. Okay, so what is the unit for B? It is V by I. So unit is ohm. This is I by I, no unit. Okay, so in this way we can able to calculate the parameters B and D. So half section is over. Now what could be the second half? The second condition. What is the second condition? When I2 becomes 0. So let us see. Now what is the second condition? The second condition is when I2 becomes 0. It will behaves like it should be replaced by open circuit. So from first equation, what we can write? V1 equal to, so if I2 becomes 0, it will be AV2. So from this, what we can write? A as V1 by V2. From second equation, I1 as C into V2. So C is I1 by V2. So under this condition, we are redrawing the network. Okay, like this. This is 1 ohm, 2 ohm and 5 ohm. Because this I2 equal to 0, we cannot disturb the input port. So keep I1, V1 as it is. So I2 becomes 0 means it got open circuited. It doesn't mean V2 0. V2 will be there. So write like this. And look at the parameters A and C. Both were in terms of V1, V2 and I1. So V1 is the supply voltage. Don't do any calculations. And if we calculate I1 and V2, that's it. We'll be getting the parameters A and C. So you can see this 2 ohm, there is no current passing through the 2 ohm, so I can neglect that. So if I neglect, the network seems to be like this. Okay, this is 1 ohm, this is 5 ohm. Okay, this is input port voltage, input port current. So straight away I'm having the tapping here. Okay, so here we got V2. Okay, so now how to calculate? This is simple loop, no? So I1 is what? V1 by, so 1 and 5 both were connected in series, so 6. Okay, so keep this relation. We'll be using it a bit later. And now we need to calculate V2. So what is V2? Voltage across 5 ohm. So V equal to IR is the formula. What is the current flowing through 5 ohm? Is it not equal to I1? Yes. So this is 5I1. So you got the relation V2 in terms of I1 also. So therefore, what we can calculate? A as V1 by V2. What is V1 from this particular relation? V1 equal to 6 into I1. So write like that, 6 into I1 by V2. Instead of V2, we may write 5 by I1. So I1 gets cancelled. We'll be getting some value which is dimensionless, no unit, because voltage by voltage. Now, what is C now? C is I1 by V2. So what is I1? I1, don't write anything for I1 because we got V2 in terms of I1, no. So directly it will get cancelled. So keep I1 as it is. Instead of V2, what we can write? 5 I1. So I1 gets cancelled. You'll be getting some value because it is I by V. Keep the unit more. Okay, so in this way we can do the problems. Now let us go with the inverse transmission parameters. Okay, inverse. Okay, inverse transmission parameters. Now, in normal transmission parameters, we have expressed input port variables in terms of output port variables. But now in reverse or inverse transmission parameters, we are going to express output port variables. That is, what are the output port variables? V2, I2 in terms of input port variables. What are the input port variables? V1 and I1. So minus, again same concept you can apply. Okay, so directly I'm writing here. So this is V2 minus, this is V1 because we have to consider the input port. Okay, so this is V1, this is I1. Now the transmission parameters are ABCD, right? Now we are writing for inverse. So make it as A prime, this as B prime, this as C prime, and this as D prime. So these are the equations for inverse transmission parameters. And now it is very easy how we can calculate ABCD parameters. In the previous case, we have used the conditions. No, here also we are going to use the conditions. When V1 becomes 0, what happens? It will behaves like a short circuit. Okay, So it will behaves like a short circuit. Now from the first equation, V2 equal to V1 0. So that means minus B into I1 we will be getting. Now what is B? This is minus V2 by I1, V by I. So unit is ohm. Now from the second equation, I2 equal to, so V1 0. So you'll be, sorry, here B prime you are supposed to take. Sorry. Okay. So next D prime into I1. So D prime equal to what? I2 by I1. Minus is there. So no unit. I2 by I1, no unit. Now what is the second condition? The second condition is when I1 equal to 0. So we'll be getting open circuit. From first equation, V2 equal to A prime V1. So what is A prime? That is V2 by V1. No unit, voltage by voltage. So from second equation, I2 equal to C prime into V1. So what is C prime? That is I2 by V1, I by V. So kabatti minus mho. So in this way, we can find the inverse transmission parameters also. I hope this video will get you some clarity about transmission parameters, cascade connection, and then inverse transmission parameters. Okay, so thank you so much for watching this video. See you in the next video.